Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking Hortonworks and Oracle for sponsoring today's event. Both Hortonworks and Oracle have been longtime supporters of the Data Science Central community, and we are honored to have them sponsoring our webinar today. I'd like to also take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Cisco, Tableau, Platfora, Splunk, and Teradata, to name just a few. These past webinars are available on demand on datasciencecentral.com, and I'd encourage you to take a look if you've not had a chance to do so. Today's webinar is entitled Data Transformation and Acquisition Techniques to Handle Petabytes of Data. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have two panelists that I'll introduce to all of you in just a few moments. We should have about 10 to 15 minutes for Q&A following the presentation, and this event is being taped and will be made available later on this afternoon on Data Science Central. I'd also like to encourage our attendees to ask questions throughout the presentation. We will be reviewing them and presenting them on your behalf during the Q&A portion of today's event. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I'll be your host for today's webinar. I'm very pleased to introduce today's speakers, Tim Hall of Hortonworks and Jeff Pollock of Oracle. Tim is the Vice President of Product Management focusing on the enterprise customer segment. Prior to joining Hortonworks, he was Vice President of Product Management at Oracle, where he was responsible for leading Oracle's outbound product management team covering the Business Process Management Suite, SOA Suite offerings including Oracle Event Processing, and the Data Integration Suite. Tim holds a Bachelor of Arts degree from Claremont McKenna College in Science and Management with a concentration in physics. Jeff is the Vice President of Product Management at Oracle for the Oracle Data Integration pillar. Previously, he was responsible for IBM information integration products. He's an industry visionary for data integration, governance, and a book author. Fueled by his passion for data and metadata, Jeff developed semantics-driven middleware while CTO and engineer for Cerebra, Modulant, Ernst & Young, and Amgen. Thank you both for being with us this morning. Looking forward to your presentations. An organization has to become more aware of the importance of big data technologies, such as Apache Hadoop. Many struggle to determine the right architecture to integrate with their existing analytics infrastructures. To truly tap into the business benefits of the big data solutions, it's imperative that simple tool-based methods are available to get data in, change and transform it, and keep it continuously updated. In today's webinar, you'll learn how the Oracle and Hortonworks solution can accelerate developer productivity, optimize data transformation workloads for Hadoop, lower the cost of data storage and processing, minimize risk in deployment of big data projects, and provide proven industrial scale tooling for data integration projects. So before we begin, I'd like to invite our audience to participate in a short poll to get an idea of where you are in your Hadoop journey. So please take a moment to just click on the appropriate selection you see there. So where are you in your Hadoop journey? Are you researching options, currently evaluating some software? Are you deep in a trial, in production with Hadoop cluster, or you're not sure what Hadoop is, which I'm sure is not the case, but please make a selection now and I'll proceed. We can all see the results, and I will then pass this off to our presenters. So there you go. Thank you all for participating. So with that, Tim, I'm going to transfer the baton off to you, and you can begin as soon as you're ready to go.
Thanks, Tim. So good morning, everybody. Good afternoon, good evening, depending on where you're located. This is Tim Hall. I lead product management at Hortonworks, as Tim mentioned, and happy to be reunited with my former colleagues from Oracle, including Jeff. Had great experiences working with the data integration team at Oracle, and super excited to be reunited and partnering with them again here at Hortonworks. I know some of you were commenting, what is Hadoop? So hopefully we'll clear that up in the presentation today. And then for those of you that are at different stages of your journey, hopefully between Jeff and myself, we can provide some highlights on what we mean by the modern data architecture, how Hadoop can help with achieving that, and the role of the Oracle data integration tools related to Hadoop itself. and in particular, the Hortonworks data platform. So today we're going to look at the drivers for the modern data architecture. We're going to look at customer adoptions and customer journey, broadly speaking, about how folks are taking on new analytic applications based on different types of data that you have access to that perhaps you've been ignoring or maybe underserved within your enterprise. We're going to look at Hadoop as a core for what we call the data lake or data reservoir, and specifically how Hortonworks and the Oracle Data Integration products work together in this context. And then Jeff is going to go through a deeper dive on the Oracle patterns for a successful data reservoir journey. He's going to talk about data integration strengths and how that connects up with Hadoop, and in particular the Hortonworks data platform. And then we're going to touch a little bit on data governance, which is focused on how do you know what you've landed in your data lake. So as you collect, curate, manipulate all kinds of data sets, we want to help you avoid what we call the data junk drawer. Everyone has that drawer in their kitchen, I'm sure. It's got a lot of stuff in it, and we want to make sure that that's not the case with you storing larger and larger amounts of data. And then we'll get into Q&A at the end. And again, as Tim mentioned, please go ahead and post your chat questions to the window, and we will see how many of those we can get through at the end of the session. So without further ado, one of the things for those of you who are not familiar with Hadoop and sort of what the goals and motivations were, we're looking at the challenges of sort of the existing data storage infrastructures, whether that's relational database systems or enterprise data warehouse or query engines that exist. And those have been focused on sort of existing structured forms of data, supporting online transaction processing systems, applications, many of which come from Oracle. But the challenge has been that we have a lot of digital exhaust. We have a lot of new data types that have been arriving, whether it's server logs or unstructured document emails, geolocation information. Everyone has probably heard about or at least been exposed to the notion of the Internet of Things, which is driven off of sensor data or machine data. And the question is, how do we deal with everything from clickstream to sentiment data coming from social media? It doesn't necessarily fit nicely within the existing relational database structures. And frankly, the volume of this digital stream that are appearing from these different sources is difficult to handle. And we're talking about 2.8 zettabytes of data, and that's 2 years ago. And this is more than doubling every year. 85% of that data coming from these new types, and machine data is continuing to grow extremely rapidly. Everything from connected car, connected home, connected cities. There's tons of examples out there of what's happening. And so the question is, how do we deal with the arrival of all of this data and turn it into something valuable that the enterprise can use? So at Hortonworks, our belief is that Hadoop is fundamental for this notion of the emerging data architecture, and frankly is an augmentation for what you have within your enterprise today, meaning we're not focused on a rip and replace strategy. We're focused on how is it that we can help you deal with all of these new data types and assets and turn them into valuable information that your enterprise can use. And then how does that sit next to your existing repositories, whether they be relational databases or enterprise data warehouses, and how can you continue to use the tools that you may be familiar with to tap into these new data sources? And that's what Oracle is helping us do. So if we look a little bit deeper, again, new types of data, sentiment analysis. This is coming off of social media, trying to determine what people think about your products, your services, what you're delivering to the market. And there's tons of feeds of these things that are existing. And we're not just talking about Twitter, Facebook. There's a large number of social media sites that now provide access to this information. And it's used in everything from ad placement to determining, for example, that you've had a spoilage factor. So I remember a use case where a large A retailer identified that one of their trucks had actually exceeded the temperature capacity that it was needing to keep the food from spoiling on its route to the store, and then ended up putting a sandwich in the cold case that had spoiled, and they found out about this through social media. I think they've swum upstream from there. They put sensors now in the trucks so that they can actually monitor that data in real time and prevent spoiled sandwiches from showing up in their cold case. But interesting approach for how to use sentiment data to determine and prevent sort of a negative business impact. Clickstream, obviously there's lots of weblogs that exist out there. What do you do with that? How do you take advantage of it? How do you optimize a shopping experience, a retail experience through your website? Why are people abandoning their shopping carts at a particular stage in the transaction? Sensor data, again, everything from connected car to shipping, containers, the long-term promise of having your refrigerator tell you that you're out of something and sort of building a shopping list for you is the extreme example. Geographic data, this is a geofencing application, understanding where people are moving. I know Oracle has a compelling use case for Wi-Fi offloading related to their complex event processing technology. Server logs, helping IT support IT better. So looking at patterns that emerge from all the different server logs that are being generated, and this is largely semi-structured data. And when I say semi-structured, what I mean is it doesn't fit neatly, tightly within the notion of a relational database system. It certainly can be manipulated through an extract, transform, and load process into such a format, but it does need to be manipulated. And I think between the ability to store this information raw and the tools that Oracle provides will show you how to deal with all of these new types of data, semi-structured and unstructured. And so one of the questions we get a lot is, this Hadoop thing, is this just like bleeding edge technology? Is it just for the telco and the financial services space that are typical early adopters of anything? And the answer is no. I think between the customers that Oracle and Hortonworks have been able to obtain over the last few years, we have examples across nearly every vertical. And this includes some folks that are typically later adopters than others. Healthcare, public sector tend to be later adopters. Retail tends to be one of the latest adopters of all, just based on margin and IT spend, and yet we see a very large number of customers in the retail space eager and hungry to take advantage of information that they have access to but have been unable to monetize previously. So hopefully this gives you a sense in looking at all the different examples here that big data is here. It's arrived. It's getting bigger every day. We're not talking about gigabytes anymore. It's petabytes and zettabytes that we're looking at now, and we want to provide you with the access and ability to make the most of all of these digital assets that are arriving and you have access to on a regular basis. And of course, one of the things that we're seeing in terms of adoption of Hadoop and how folks are taking advantage of the cost-effective storage of all of this information and then the ability to analyze it is that it typically starts with an idea. And the idea is a new analytic app. Hey, wouldn't it be great if we were able to take this information from these different sources and drive some sort of business decision out of it? We want to offer a discount on a particular subsegment of customers. We want to ensure that we have perfect visibility in terms of fuel consumption, distance, and the temperature readings in our trucks in order to make routing decisions or other fuel optimization decisions, etc. And it normally starts with that question: what information do we have, and how can we leverage it? So that first app typically gets built on top of Hadoop by ingesting one or more of those sources of data, combining it, and then offering it back out in a meaningful way. And what ends up happening after these different data segments are loaded is folks find out the power of Hadoop in terms of being able to combine, manipulate, and leverage this data in new and interesting ways, bringing new sources of data in, combining it with what's already there, and effectively delivering on this notion of a data lake or a data reservoir, as Jeff will mention. And the idea here is that Hadoop is the fundamental enabler of that, from the context of being able to consume and ingest and manipulate all of those different types of data in a cost-effective manner, and then allow you to build those net new applications on top. So this is not intended to be a replacement for online transaction processing systems. It's intended to augment what you can do in terms of these large sets of data and answering these questions in the most efficient manner possible. And in many cases, you weren't able to do that previously, given the scale at which this data was both arriving and needing to be processed. And so in the context of this modern data architecture and the relationship of what we have at Hortonworks in terms of the Hortonworks data platform and how it relates to the various tools and capabilities that Oracle provides, hopefully this graphic gives you a little bit of a sense. Number one is the Oracle data integration products provide an ETL capability through ODI. And that can both tap into those existing sources that we showed you earlier, relational databases and data warehouses, but now can also leverage Hadoop itself. And Jeff's going to go into more detail on this in a few minutes. But of course, Oracle has a fairly broad and deep set of technologies that span not only data integration, the core relational database systems, the data warehousing capabilities, and operational tools through things like Enterprise Manager, and now infrastructure capabilities through their various EXA appliances. Now, in the context of what we're doing in terms of partnership, Hortonworks has spawned a number of initiatives. Number one is we do certify with our partners against our distribution of Hadoop, which is 100% open source, comes from the Apache Software Foundation. We try to stay as close to the trunk as possible, ensuring that you as a customer get the maximum value out of the open community. And together we work with a very large ecosystem of partners, including Oracle, to certify their tools and technologies on our latest releases. And so in the context of what we've done thus far, we've been very focused on ODI, the Oracle Data Integrator product, and the big data connectors to ensure that they work effectively with HDP. In addition, we have a sandbox that's downloadable from the Hortonworks website. So for those of you who are just starting your journey with Hadoop and would like to get a better sense of what you can do with it, there's a whole series of tutorials, and there's a form factor that you can download. I believe it's about 2 gigabytes. You can download in a virtual machine. Oracle Virtual Machine is one of the packagings that we have up there, and then a whole series of tutorials for you to explore exactly how to take advantage of Hadoop. And then last but not least, one of the things that we've done is we've been very focused on something called Yarn Ready. And then for those of you that are not familiar with Hadoop, Hadoop originally started as a sort of largely batch-oriented system. Given the volumes of data that we're talking about and the manipulation of that data that needed to take place, it was very focused on sort of this batch orientation. And what's happened over the last few years is part of the fundamental technology has shifted to allow for real-time, interactive, and batch processing to occur on the same set of machines. And the thing that's enabled us to do that is the introduction of a capability in Hadoop called Yarn. Yarn stands for Yet Another Resource Negotiator. Terrible from a marketing perspective, so you know it was named by an engineer. And Yarn is really the thing that unlocks all those different capabilities. And how does it do that? In essence, it allows you to schedule jobs on the cluster and allows you to maximize throughput and efficiency of all the compute resources that sit underneath. And so one of the things that we've been doing, in addition to just sort of core certifications with partners, is we've been looking at how those partners take advantage of Yarn itself as this fundamental substrate of Hadoop. And you'll see us go further down the path here in terms of offering additional certifications for things like management, security, and governance. So again, big focus for us on helping existing software vendors leverage the power of Hadoop, focus on delivering this to customers in a cost-effective and efficient way, and augmenting the tools and capabilities you currently have in your data center. And with that, I'm going to turn it over to Jeff to talk about Oracle Data Integration and governance.
Awesome, Tim. Thanks a lot. Really appreciate it. Before I jump right into the big data topic, though, I know this recording will live on in posterity for a while, but I wanted to make recognition that we are recording today on 11/11, and I wanted to recognize all those that are serving or have served in the armed services, and they make it possible for all of us to do what we do. And just real quick, two individuals I wanted to call out: Ryan Pitts, an Oracle business development professional, and also Congressional Medal of Honor recipient, and then a mutual friend of ours, Tim, from IBM. Rich York, former Army Ranger, two guys that are both involved in the big data and integration community, and just wanted to thank them for their service. As you know, those on the phone already know, I've been, I should say, on the Hortonworks and the Oracle side, I've been on a whirlwind tour of Europe the last couple weeks, and Tim, as you know, I've been visiting some of our joint customers here. I was chuckling to myself in your earlier remarks. A number of those joint customers are, of course, from telecommunications and banking, and yes, they are the early adopters. But fortunately for us, they're also the ones that stress test and kind of push all of the software to the upper limits early on as well. So it's been really powerful to see a lot of those use cases that just even a year or two ago were science projects now going into full-scale production at very, very large scale. So also worth noting, as you've pointed out, that a number of the clients that I visited here of our joint customer base in Europe in the last few days, they've also been in the retail sector, they've been in the media sector, and as well as the public sector. So this has been, as you point out, something that's been a groundswell, I think, on both sides of the Atlantic, and also with our joint customers in Asia as well. So one of the things that's really been a common story here, as you point out, is as folks are moving to combine newer data types, and this application exhausts the log and the click streams that are coming from the newer data sources that folks are looking to leverage. The common theme has been that they need to combine that in most cases with existing investments around tooling and infrastructure, as well as with existing data, which historically has been structured. And so as we have looked to put together the portfolio from Oracle that really aims to solve that comprehensive data integration and data governance footprint, what we've been focusing on is making sure that we've got capabilities that cover everything spanning from the dynamic data movement infrastructure, where it is based on very low latency, low impact, and continuous data staging principles, into Hadoop, often aligning with, as you pointed out, the shift in the Hadoop community happening very recently, more and more towards the streaming and the interactive use cases rather than the batch use cases. We're looking to align this technology from Oracle, the Oracle Golden Gate technology, with all of these newer capabilities in big data. We're also continuing to leverage, from a data transformation standpoint, the power of the Hadoop engine. We absolutely believe that going forward, the ETL processing will shift away from the proprietary infrastructures of yesteryear, as well as and more towards the open source and, as you point out, the core trunk platforms. And that increasingly has been all of the frameworks and technologies on top of Yarn. And this is inclusive, of course, of the batch mode of operations, as well as the interactive and the streaming mode of operations. And this is where we're investing with this technology from Oracle Data Integration as well. We also see increasingly the role of the data federation environments for virtualizing data access down into the core Hadoop layers, as well as, of course, from a foundation of governance, being able to manage and have visibility into the end-to-end data flows, not only within the data flows that exist within the data lake and the data reservoir, but also weaving that and stitching that together with the metadata and the business glossary information that already exists in many cases from our traditional business intelligence analytics environments, as well as from our application and data modeling tools that the information management professionals have been using for many, many years. And so the objective from the Oracle perspective, as always, with the Integration and Governance Foundation is to really be the Switzerland, so to speak, in the industry. By definition, as an integration vendor, we look to support Oracle as well as non-Oracle technologies across the board. And frankly, we see the adoption and the interest around the data lake and the data reservoir style of architectures precisely because our customers are looking to bring together and manage data that's coming from so many different sources. And one of the things that's been very powerful in the past few months as we've been going around together, Tim, and speaking with our customers is guiding them towards the route of how to be successful in deploying the data lake and the data reservoir architectures early on. And this is something that I think even as recently as a year or two ago, there were still many open questions about how to be successful with adopting the Hadoop and the big data infrastructure. And what we've really seen is the patterns emerging, I think, across our organizations, is that it's most powerful and most successful when folks look to bring together the big data technologies with their data warehousing technologies and tying that directly to a business initiative that has an ROI attached to it, or that has a business program attached to it that can actually be measured and results can be drawn forward in a very purposeful way. What I've seen is most successful implementations, often taking an iterative approach towards delivering incremental value on short cycles, taking this approach of minimum viable product where it cuts across functional delivery and the combination of business and IT plan together, how to deliver continuously over these short iterations. I think this has been key to a number of the organizations whom I've seen personally able to move very rapidly from inception phase of the project into now rolling out production scale infrastructure where the big data infrastructure is tied directly to the mission critical analytics systems that have been running for many years in the IT environments. And the third point that we'll mention here is that we've seen that this technology cannot be rolled out in isolation from all of the existing investments and the existing data that our customers have put in place over the years, particularly when we look at the analytics and the business intelligence infrastructure. In many cases, there are many investments already in place and lots of data modeling and thought that's been put into the information management infrastructure. And what we see as a successful practice is incorporating the Hadoop and the big data technologies alongside these investments by leveraging tools and not only trying to recreate the wheel by custom coding everything. And so these patterns for success have been something that we've seen quite often when we look at these joint deployments coming together across the technologies. When we look at moving beyond the business practices for success and drilling into specific use cases, there's been three areas where we've seen real strong levels of adoption and I would say strong levels of success by project where we've been able to establish a business case and an ROI. And these really rest on driving some of the core foundations of what we see as again and again the shift in value that the technology of big data and Yarn and Hadoop provide here in terms of introducing the capability for schema on read, introducing more of the elastic compute capabilities around both compute and storage. And these three use cases are around delivering the data sandbox for more rapid provisioning of newer types of analytics. Secondly, providing an infrastructure to shift some of the more expensive ETL operations off of proprietary servers and off of expensive staging areas into the distributed compute resources that Hadoop provides. And then third, being able to provide a queryable archive for long-lived data or aged data that needs to be made available for compliance initiatives, and really leveraging the elastic storage capabilities of Hadoop for that infrastructure. And to just kind of drill a little bit further into each of these use cases, the traditional ways that we've done data warehousing in the past have often been associated with waterfall-style delivery methods, or even when projects have attempted to use more agile methods from a delivery standpoint. By definition, when we do traditional data warehousing, we have to do a lot of data modeling up front. And with that data modeling comes a lot of mapping work with ETL. And we have to stage the data, and we have to iterate on highly structured infrastructure in order to deliver these reports and these dashboards in the traditional models of analytics. And what we're seeing now with this value proposition around sandboxing, it's been line of business led, and it's been the business who's been communicating that it's not acceptable anymore to have to wait 6 months or 9 months for a dashboard or a report. And so what we see is leveraging the Hadoop infrastructure, the Yarn infrastructure, in the Hortonworks data platform as a way to create a sandboxing environment to deliver analytics more quickly, more on demand, to deliver a provisioning environment that can be done rapidly and spun up and dropped elastically in response to the demands of the business. And here we're really taking advantage of these schema on read capabilities to deliver these hot provisioning zones and to really deliver business access to their data in time frames that even 3 or 4 years ago just were not possible on traditional technologies. And so this first use case around data sandbox has been very important, especially as we evolve the data platform capabilities in parallel with a number of the data discovery and the data exploration style of analytics tools that are being deployed on top of the data platform here. The other big use case around ETL offloading is that over the years, a number of the largest data warehousing vendors have advised that we put our staging tables for data and that we do much of our data processing directly in the data warehouse. And so we've built these large data warehouses that have a lot of storage allocated for data staging and a lot of compute and batch windows associated with stored procedures and associated with scripted SQL processing in the data warehouse. And what that's created in many cases is an environment that makes it more challenging to manage batch windows and more challenging to scale and keep up with the pace of growth in the warehouse. And so now what we see is really IT-led initiatives around cost avoidance to shift a lot of that compute and a lot of that storage for staging into the Hadoop layers, and really leveraging the power of the elastic Yarn capabilities for compute and storage and driving that ETL offload. The other thing that I'd mention here is another area that's been optimized is the use of proprietary ETL engines. A number of ETL engines over the years have actually developed their own distributed architectures, which in many cases require a substantial hardware investment in clusters and grids of compute resources simply to process ETL off of the warehouse. And so where traditional ETL vendors that depend on engines have made a significant amount of overhead for their customers is in the investment of that ETL infrastructure in front of the warehouse and alongside the warehouse and around the warehouse. And now with Hadoop, we're able to leverage a more interesting distributed architecture that can actually be used for different kinds of workload in addition to ETL. The third thing that I'd mention is around use of the Hadoop data platform for compliance initiatives. A number of our banking and insurance customers that have been going down this route have risk management and compliance initiatives where they need to maintain detailed data for many years. And anybody who's been in the data warehousing space for a while, what we've been doing with data warehousing, as most know, is that we can keep many years of aggregate data often in the warehouse without any trouble, but many customers over time have to delete the detailed data that's been used to compute aggregates in the warehouse. And so what we're finding now in the stricter compliance era that we live in today, it's actually important to keep that detailed data, and sometimes for perpetuity. And so a number of our larger banking and insurance customers I've seen moving to what we call a no-delete policy for data. And what we need to be able to do is make this data easily accessible through the SQL and relational database technologies, but to have the cost optimizations that the Hadoop infrastructure provides for the deep data storage, often in the no-delete and in perpetuity type of approach. So these are some of the use cases and patterns that we see from Oracle. And what we're doing around our tooling infrastructure is really optimizing our infrastructure to meet these requirements and these use cases in the most effective way. And so there's a couple of things that we're doing different at Oracle that are really unlike anything that any of the other vendors are doing around supporting these patterns of infrastructure on Hadoop and big data infrastructure. And what we've done with Golden Gate, as an example, is our architecture is a real-time architecture first. And so what we mean by that is with our architecture, the way that we actually do the E and the L, if you will, of an ETL process is that we leverage the Golden Gate infrastructure for capturing transactions in real time from the source systems, and then making those transactions available within the big data environment. And you'll see in just a minute, with Golden Gate, we can actually support a variety of technologies within the Hadoop frameworks. We can load directly to the ARM-based services in Hive and HDFS and others, but we can also place the Golden Gate transactions on streaming technologies like Kafka and Storm, as well as making those transactions available for the streaming analytics platforms that are so popular now. Now, this approach with Golden Gate has the benefits of being able to completely eliminate the need for managing batch windows on the sources. This is something that if you look at the default reference architectures from a number of other vendors, they're by default advocating the use of technologies like Scoop, which are by default batch-oriented. We're by default taking a non-invasive approach by taking transactions from the logs. And we have the ability with Golden Gate to actually move the entire transactions and make full replicas of the sources, or we can actually also just move the changed data so that we're only replicating the changes over time. And so this is really the most proven replication tool by far on a worldwide basis, and we've actually completely married this up to be complementary to a big data environment, and really answers the question, I think, of how do we get the data into the Hadoop environment much more elegantly than any other technology on the planet can provide right now. But that's not the end of the story from a data processing standpoint. What we need to be able to do next is seamlessly move the data within and around the Hadoop cluster or the zones in the Hadoop cluster for not just the staging, but also making the data accessible for provisioning in the sandbox, for doing the ETL offloading work, as well as for moving into potentially a canonical or a normalized model for archiving. And for that technology, we leverage Oracle Data Integrator, which is an engineless ETL tool. It completely uses the Hadoop infrastructure for processing the data. We can process using the MapReduce technologies, but we can also process using some of the other non-MapReduce technologies within the Hadoop environments as well for optimizing depending on the level of interactivity that's required for the data transformation jobs. And so this is a much more integrated approach. It's also the only tool on the planet right now that has a complete decoupling of the logical mapping from the physical mappings. And so we can take the exact same logical mapping environment and deploy that in different physical computation models within the Hadoop cluster, and this is completely independent from the physical architectures that you choose during the mapping and design stages of using the Oracle Data Integrator tool. But usually when we go through this process of describing the data movement and the data flow, the very next question that we receive from our customers as they're deploying is, that's great, but how do I govern and manage all of this information flow now that I've introduced Hadoop into the architecture? And what we're able to do with Oracle is provide a metadata management and business glossary capability, as well as data cleansing and data profiling capabilities that allow us to work directly with data coming from the Hadoop clusters. With our metadata management and glossary environments, we can scan directly from the H catalog. We can scan directly from Hive and HBase. We can bring in a number of different metadata environments from of course, multiple distributions, but also, of course, the Hadoop data platform is one of the core that we continue to support out of the box. So what we're really aiming to achieve here is a comprehensive solution that works with Hadoop from a data movement perspective, getting the data into the Hadoop environment, seamlessly transforming and moving the data within cluster across many different logical zones of the Hadoop infrastructure, and then, of course, onward to both Oracle as well as non-Oracle target destinations outside of Hadoop, and then governing the entire infrastructure with metadata management, business glossary, data profiling, and data cleansing capabilities from an end-to-end basis. And so this is the vision, and this is the approach that Oracle is taking with that infrastructure. What I want to do now is just drill in for a moment on each of the components in this architecture, starting with Golden Gate. And first I'll point out that we have Golden Gate customers in production today targeting all of these technologies that you see on this chart. And this is really critical. Tim, I'm glad you introduced at the beginning of this call the fact that we've really seen the sea change begin to happen, where we have customers complementing the batch-oriented style of processing in Hadoop now with the streaming and the interactive approaches as well. And so with Golden Gate, we can capture transactions, database transactions in microsecond level latency as they're happening from the source side, and we can move the full records or the partial records in real time and deliver those to any of the technologies that we see listed on this chart. And so in some cases we're writing transactions to file in HDFS. We can deliver directly to the HBase APIs. We can deliver directly to Hive formatted data structures into Hive, and increasingly we see customers looking to leverage streaming technologies like Flume and Storm, as well as pub/sub infrastructure like Kafka, in order to take advantage of this data while it's in motion. And this is key because, again, with Golden Gate, we're delivering these transactions in very low latency timeframes, and we're making the data accessible to the real-time analytics infrastructure, and then also to staging and micro-batching. For example, within Storm, we have the Trident infrastructure for micro-batching, and all of these services then become instantly capable of accessing database transactions from Golden Gate within microseconds of the commit statements having been delivered on the source relational databases. So this is a very powerful integration across the board. And of course, not to leave out some of the wonderful work happening recently around Spark and Spark streaming. We see a lot of these interactive machine learning type use cases being important, not just for analytics, but also for ETL workloads, and having Golden Gate deliver transactions for staging into these environments is crucial as well. I wanted to take just a minute, Tim, here to mention again why Golden Gate is superior than some of the other so-called real-time approaches coming from other vendors. What we're able to do with Golden Gate here is continuously stage the data in real time from the relational sources over into the Hadoop environments. Our reference architecture from Oracle leverages real-time by default. Golden Gate is the preferred and default reference architecture. It's the first-class approach from Oracle, and how we do the E and the L from extract and load perspective. And this is where, going forward, we see really the more mature Hadoop implementations leveraging a staging area and a streaming capability that has instantaneous and real-time visibility on relational data. And the way that we do this is with Golden Gate. We, of course, also have support for Scoop. I don't want to leave this out, but the batch style of architecture is something that we see evolving over time to be more of a continuous data architecture, and we believe we're ahead of the curve on this, and this is why we've placed this as the default reference architecture from Oracle. We're the only vendor on the planet right now that has an integrative native capture capability with the Oracle database. We, of course, test and evolve this capability with every patch cycle that we deliver from the Oracle Database Foundation. And this, I haven't seen the latest market share, but certainly Oracle is half or more than half of the database market in the world right now, and it's the Golden Gate technology that actually provides the most reliable and the most robust connectivity into that framework. And so this is something that will continue to evolve, and frankly, we have Golden Gate customers that have already bet the business on the high availability use cases with Golden Gate, and this is something we're quite comfortable with at extreme data volumes from a Hadoop standpoint, moving vast amounts of data into Hadoop using the same Golden Gate technology that businesses rely on for high availability. And so this is also mentioning those high availability use cases. It's the most widely proven technology on the planet. We have many, many thousands of customers, most demanding environments for systems that need 7 nines of uptime capability. And this is the very same technology that we're using as we evolve forward to support these Hadoop use cases where we need to see data in Hadoop in real time. So I think that the Golden Gate Foundation for us is something that we're absolutely leveraging and exploiting to make sure that modern Hadoop deployments for streaming, interactive, and even staging for batch mode style of operations are leveraging the Golden Gate infrastructure for getting data into those environments. We also have the Data Integrator technology footprint within the technology stack. This is key for us so that regardless of whether in some cases folks will continue to use Scoop for batch loading into the Hadoop and Hortonworks platform, but as these evolve over time to Flume as well as Kafka and Storm and indeed Golden Gate directly, no matter how the data arrives, the next steps in processing most often involve some types of complex processing. And for these complex processing types of use cases, we're looking to really use Oracle Data Integrator as the tool to describe the complex transformations. And then this is crucial with that single environment for mapping and modeling complex operations at a logical level, be able to seamlessly switch between deployment models. And this could be Hive on MapReduce, this could be Hive on Tez, this could be Spark-based interactivity, this could be transformations running with Pig, Pig on MapReduce, Pig on Tez. So as we roll forward with Hadoop as a platform, there are going to be many, many choices that Hortonworks customers have on which frameworks to leverage within the Hortonworks data platform. And depending on the use case and the complexity of the data transformations and the level of interactivity, the level of machine learning that needs to occur, what we aim to achieve with Data Integrator is an environment where you can model the transformations and the functions independently from the technology platform, so that as the use case evolves or as new technology emerges, that we don't have to send our customers back to the drawing board to remap and to retool their mappings and their transformations. And so this is very much the design philosophy of Oracle Data Integrator. It's the only tool on the planet that was actually designed from scratch to be a code generator, and it's precisely why Oracle Data Integrator has this decoupled architecture where we can cleanly separate the concerns and allow the same mappings and the same models to be generated in a variety of different physical frameworks. And so this is where the Oracle Data Integrator investment has been today, and it's going to be where we continue to invest going forward. And I wanted to show, I realize this screenshot's a little bit difficult to see, but for those that are looking at it on a big screen, what I'm pointing out here is this little icon with the green arrow. When you execute the runtime for ODI, what we're actually doing is we're pushing down and generating code, and this could be Hive queries, and we support Hive on MapReduce and Hive on Tez. This could be Pig infrastructure executed in a variety of ways. This could also be Spark infrastructure, and importantly, there is no deployment of ODI where the data has to flow through some proprietary code that Oracle has for Oracle Data Integrator. The actual data and the actual data transformations that are running in Hadoop are 100% native to the Hortonworks data platform, and it's really just the ODI tooling that's generating and orchestrating those data flows. And over on the right-hand side where it says the runtime execution can be UZI or via ODI Java agent, to emphasize the point, we actually have two options here on how the orchestrations are done. So we can orchestrate the Oracle Data Integrator jobs via the Java process that is the ODI process. And again, the data won't flow through that ODI process. It's merely orchestrating and generating transformation code. But we can also deploy and run these processes via what we call an UZI local agent. And so the UZI local agents can actually deploy natively within cluster and execute completely independently of any ODI runtime whatsoever. And so we have a variety of innovative options here for pushing down and deploying Oracle Data Integrator execution 100% natively within the Hortonworks data platform. We've also, as I've mentioned before, separated the logical and the physical design, and so I'm pointing out here the tabs on the user interface such that you, when you model the data transformations within ODI, you quite literally have a logical view, and then you have a physical view. And then in your physical view, you can actually specify different physical materializations. And so you can materialize the physical view here as SQL-based transformations, as Hive-based transformations, as Pig-based transformations, as Spark-based transformations. And internally, what ODI will do is automatically generate the different runtime orchestration, the different physical generated code to then run these transformations natively in whichever physical platform you deploy. So this is quite an innovative and quite a different approach compared to some of the other ETL vendors. Of course, the reason why you'd want to use a tool in the first place versus hand coding everything, you get all the benefits of team-based design, being able to use the integrated source control. But importantly, ODI comes out of the box with a rich set of pre-built operators. And I'll have you note here that in the operators, we don't have a Pig join and a Spark join and a Hive join that are all sort of hard-coded to specific Hadoop technologies. What we have is we have logical operators that are independent of the underlying physical infrastructure. So unlike some of the vendors that actually have to hard code their operators and their transformations in advance, ours are completely logical. And so as you develop your logical mappings, you can use these operators, and then at runtime, what happens when you've selected your physical deployment models, Oracle Data Integrator will actually take care of that for you. So your developers don't have to think about when they're writing their mappings, hey, which technology am I going to use? They can actually go in and think in a completely logical way, and then later your architects and your infrastructure team can decide how those actually get deployed physically at runtime. Importantly, just to illustrate the case, before the ETL vendors actually began to support some of the push-down capabilities, the traditional tools would operate completely outside of the Hadoop infrastructure. You had an ETL engine that would process some data, that would actually load the Hadoop infrastructure quite separately, and then if you needed to move some data out of Hadoop and onward to other targets, again, the ETL engine would be processing quite separately from that. This, of course, is not acceptable. And what a number of the ETL vendors have done is they've now taken some of their proprietary ETL engine code and they've federated that so that it can work in a distributed way on the same machines that the Hadoop clusters are running. But don't be fooled by that, because what's actually happening is that these ETL vendors have taken their own proprietary engine code and they're running it alongside the Hadoop infrastructure but it's not necessarily the Hadoop infrastructure itself that's actually processing that environment. And so you need to look very carefully at what is native versus just cohabitating on the same clusters. And so this type of distributed proprietary ETL approach is what we might say is an on Hadoop approach rather than an in Hadoop approach. What we all aim to strive for in the partnership between Hortonworks and Oracle is actually putting the open source technology at the center of the ETL processing. And so if you're not using a tool, what that means is you're scripting and writing Scala, or you're writing Pig natively, or let's hope you're not writing MapReduce natively here down at the assembly level. But if you're doing it without tools, most likely you're writing a lot of these jobs, if you will, directly. And of course, this is an anti-pattern that, going back 15 and 20 years, this was the entire reason that people moved away from writing C, C++, Pro C type operations, even stored procedures in the database manually, because over time, this type of native manual coding becomes incredibly difficult to debug. It becomes incredibly difficult to troubleshoot. As issues crop up, finding those issues and managing escalations around those issues is incredibly difficult. And so having a tool-based approach allows you to overcome a lot of this infrastructure. And what we've done at Oracle, I believe, is combine the best of both worlds. Here we've got a tool-based approach that allows large teams to work collaboratively together on an infrastructure to model and map complex data operations that run natively in Hadoop. And like I mentioned before, when we run, I should say, in Hadoop, that can be orchestrated via an Oracle Data Integrator process, but it can also be pushed down fully natively within those environments. And then I've also illustrated here Golden Gate, because I want to make sure to remind folks that while we support scoop and batch mode ingest into to Hadoop, the preferred approach is continuous data staging into Hadoop. This really eliminates the need to manage batch windows or even micro-batch windows on the source systems. And this is a huge value proposition as folks become more and more committed to full-scale operational use of Hadoop on their mission-critical applications. So hopefully that's a quick introduction into Golden Gate and ODI and why we think we've got a superior approach. Wanted to cover a few slides here on data governance and metadata management. We have a metadata management environment. It's very much focused around providing business glossary capabilities and metadata management capabilities armed at the business. One of the most popular use cases we've actually seen, I love the analogy, Tim, earlier from this, so talk about the data junk drawer in the kitchen. I've heard people talking about the data swamp for years now, but this is the first time I've heard the data junk drawer. So one of the things that is immensely powerful with metadata management and business glossary is it actually provides a catalog of what's available in the environment for your business users to access when they're looking to build analytics. And so it used to be historically metadata management really revolved around the IT use cases for impact analysis. Hey, what's going to break if I change this table? Or it evolved into a compliance use case, which is, hey, we're being audited next month. How can I go back and look at which tables populated that report? And we support those use cases. But what's interesting, actually, most recently is actually solving this challenge of the data junk drawer, which is sort of, hey, we've made it very easy to put all the data into Hadoop, but what data do I have accessible to do my data sandboxing? What can I use in my data discovery tool? And so this is something that's really, really important as we go forward with making the metadata management tools useful in the Hadoop environment. And it's much more of a use case there around data discovery. So I'm going to push forward a little bit. I'm going to push forward here, Tim.
Thanks. We're just running out of time, so thanks for moving.
Absolutely, and yeah, sorry for that. So I want to emphasize here, use cases cover both the business and IT use cases, really revolving around where did the data come from. The data governance infrastructure is really key for us as we look at making sure that we're able to support that end-to-end flow, not just the data stewards and the subject matter experts, but also supporting the business line on where the data is coming from in the catalog, that we provide around that infrastructure. Wrap up here briefly just on a few words about our heterogeneous infrastructure. I mentioned at the top of the call, Oracle is 100% committed to providing wide support. By definition, we have to be Switzerland in the industry and support Oracle and non-Oracle environments. We've got a huge list of systems that we support as sources and targets, as well as from a metadata perspective, being able to tie this together with common visibility and governance across the infrastructure. I know I've spent a lot of time here around our use cases for data integration, and hopefully convinced you that we've got a unique approach around dynamic data movement from Golden Gate, the ODI approach for being an engineless ETL tool executing natively in the Hadoop environment, and then from a data governance perspective, being able to provide that end-to-end capability around metadata management and business glossary. So I've kind of accelerated here at the end. Sorry for running short on time, but Tim, I'm going to pitch it back to you here for this final chart, and maybe you can bring us home.
Thanks, Jeff. So just to wrap up before we jump into some final Q&A, there's some additional details here about what Hortonworks and Oracle are doing together. We've got a link to the sandbox that I mentioned earlier. There's a link to learn more about the data integration suite from Oracle in particular. And of course, you can follow us on all the usual social media channels. And you can probably find Jeff and my Twitter handles there as well. So I know we got a bunch of questions, and Tim, we're at the end of our time.
Yeah, so thank you, Tim and Jeff. Great presentation, both of you. An awful lot of detail, and unfortunately we are at the end. Typically we end right on time, so I want to make sure the audience is rest assured anybody that's asked a question, we're clearly not going to get to them today, and we usually end right now, but I'm going to extend the time a little bit for some Q&A. Anybody that has to jump off, as I mentioned, we are taping the event. You will be able to check it out later and fast forward to the questions. Please take down Tim and Jeff's information. You can email them directly. And again, any questions that were asked today, of which there are a lot, we're going to be sending them to Tim and Jeff, so they will get answered. So we're just going to extend about 5 minutes here so we have a few questions. You did mention Apache Spark and a couple of references. Can you go into some detail about how you've worked with Spark?
Yeah, so let me jump in here with that just quickly on the ODI side. We have what's called the knowledge module infrastructure within ODI, and we have in Golden Gate what's called the application adapter. And actually, in both cases, we're able to directly integrate with Spark. What we've seen is that the more interactive patterns for doing data transformation in Spark can actually be very well suited where there's a large number of smaller sources or complex multi-way joins. The Spark infrastructure can actually be quite productive here. We're excited with a lot of the work that Hortonworks are doing in this area actually to bring it onto Yarn. And Tim, I'll let you answer kind of what's been going on there. It's really cool stuff you guys are doing.
Yep, so we've been working within the Spark community, looking at aspects of reliability, scale, and debuggability. We have the Spark technical preview posted up on our website. And we've announced future support for Spark once it completes sort of the current round of feature additions. We're targeting a Spark 1.2 engine within HDP and providing support for customers on that. One of the more interesting things we've been doing is looking at the Spark execution engine. People love the Spark APIs, the flexibility and the sort of ease of use. But one of the challenges has been operating the Spark engine at scale over extremely large sets of data. And we have been working within the community to see how we could leverage the TES execution engine that we have that's optimized for those large data set sizes and essentially allow you to seamlessly execute your Spark job through those expressive APIs, but using TES as the execution engine. And this is something that we've done for Hive. That released in Hive 13, where there's essentially an execution engine switch where you can move between MapReduce and TES, as Jeff mentioned. And then that same capability will be available in the upcoming release of Pig, where you have the ability to select that more optimized execution engine.
Okay, great answer to the question. And unfortunately, that's going to have to be the only question we can really get to today. So my apologies to our audience for running a little bit over. And again, all these questions that have been asked, we will get an answer for you. And again, take down Tim and Jeff's information so you can reach out to them directly. I have just a few quick announcements to make to please mark your calendars for December 9th and our next Data Science Central webinar, How United Way Embraces Visualization and BI to Drive Social Impact, which is sponsored by Tableau. Again, this is being taped, so everything will be made available later on this afternoon at Data Science Central. And this will bring our webinar to a close. I want to thank our audience again for participating, some great questions. Special thank you to both Hortonworks and Oracle for their sponsorship, and to our panelists, both Tim and Jeff, for their insight into today's topic. Thank you, Tim, also for Jeff for referencing the importance of today. I think it's important to do so, and so I appreciate you doing that. So we'll look forward to seeing you all again on December 9th, and thanks again for joining. Good day.